Ka. Alright, so I'm going to be doing two write-ups, two PWN Challenge write-ups from BYU CTF 2024. My team and we are still working on this CTF. These are all the challenges we have done so far. I was working on these two PWN challenges here, and I'm going to do a quick walkthrough of them while the remote servers are still up. So I'll start with this first one here, and it says all. What if I just put all the vulnerabilities in there with no mitigations, and then they give us a netcat, port, and a zip file. Alright, so let's just get right into it. So we get this binary, and I'm going to run all on it. It's a 64-bit executable, dynamically linked, not stripped, which is nice. We'll run checksec on it. Looks like there's no pi, no NX, no stack canaries. So just like the challenge says, there's no mitigations on it at all. And since we don't get the source code for it, I want to pull up in the assembler. So I'm using binary ninja, but you can see in the main function it just calls vuln. And in vuln there's an infinite loop that basically just accepts user input until quit is being written into the thing. And as you see here in this read snippet here, that it'll read 0x100 bytes, which should be like 256 bytes, I believe, into buff, a variable, and print f it out. So for me, when I was looking at this, I ran on, I tested a bunch of random stuff, and it's just repeating itself. I went to do GDB, and I did a pwn cyclic. I do like 500 or something crazy like that, and just crashed the program. Okay, that didn't even crash the program. Let me see. Yeah, so I tried to do that. That didn't work. So actually, I think there is an overflow vulnerability here. I wasn't able to trigger it because it was being weird like this. So instead, when I was looking at this, sorry, where was it? Printf right here. Obviously, it's missing a format specifier. So we have a format string vulnerability. So if I do something like this, you can see it's printing addresses off the stack. And so my plan of attack was to do a GOT overwrite, do format string write, leak the libc address, and overwrite this printf function with system in libc. So the problem that we have to do is to figure out which libc version they're using. But first I just want to test it locally. And what I did was, let's see, let me disable this first. Disable randomization on. Let me turn off ASLR on the GDB sessions. So first of all, I just printed out a bunch of P's, and I noticed on the 6th iteration, this is our user input, so we can overwrite. We can have a format string right now. I'm looking at these values, and this is a stack value because you can see it starts with 0x7ff. These are most likely libc values, but we can verify that by running vmmap. And we can see that 07FA should be libc addresses. So these two are libc addresses. And so what I did in my script, let me just bring up my script right now. Sorry, not over there. Over here. And test.py. In my script here, I grabbed one of the addresses and I subtracted it by the libc base in GDB. And the reason why this works to find the offset is because even though these values change, but the offset does not change for the particular libc that's being used. So what I did was I sent in %3 $P, which will print me the third value off the stack, which is a libc address, receive it, and I take that address and I subtracted it by the offset, which I calculated here. So once I got the libc.address, I can put it in pwn tools like so, and now I don't have to hardcode anything. I can just use libc pwn tools to do it. So now I start doing my format string write, fnt string underscore payload, offset 6, elf.printf, change that to libc dot symbols system, and then I'll send in /bin shell, and that should give me the flag. So let me show you how this looks like when I run this locally. Boom, and you can see it works. The problem with this is that it works locally, but we need to figure out what libc version that the remote server is using. In this case though, in our all.zip file that they provided us in the challenge, they do give us a Docker file, and in the Docker file, it is not that Docker file, but this one. It's copying everything from Ubuntu 22.04, and in my VPS server, actually, I am running Ubuntu 22.04. What's the command for that? C release. Alright, I don't remember the command to figure it out, but you're gonna have to trust me, it's Ubuntu 20.04, so I used my libc on this VPS server, and this is the proper offset for that here. So let's run it remotely. Whoops. You can see it's opening the connection. Boom. And there we go. Got the flag. Alright, so let's continue to the next challenge. It is static. And it says, so I heard all about these binary exploitation attacks involving libraries in libc, and that's got me worried. I decided to statically compile all of my binaries to avoid these attack vectors. This means I don't need to worry about mitigations, right? So it looks like we have a statically compiled binary and netcat with the static binary. So in this case, we only get the binary. So let's just dive right into it. Run file on it, 64-bit, statically linked, not stripped, which is good. So run checksec. So NX is now enabled. There is a stack canary, but it's fine because we don't. We'll find out later that there's actually no canary. Well, there is, but we never touch it in our functions. And no pi, which is nice. So we have no source code. Let's run this in disassembler and see what's going on. So here you can see it's kind of the same thing. In main, let's go here. It's running bone, and in bone it's calling. Well, it's not calling anything, but it's returning libc read on this. Let's just see what that looks like. The binary looks like. It's static. It looks like it's waiting for user input, and that kills itself. And then we get sigfo here. Okay, so it looks like there's an overflow vulnerability here. It's calling a libc read that is statically compiled, so it's inside the binary somewhere. But let's just go see and try to figure out the offset here. What I did was, and maybe I could show you here too, but I ran s.sendLine. I ran pwn underscore cyclic, or pwn.cyclic actually. 0x100, that, and do interactive. Let's just do this, see if this will. Oh, that's not what we want. Whoops, whoops, whoops. No, no, nope. God dang it. Come on. Alright. Then, please. Alright, let's get rid of this. Okay, forgot to do this too. Whoops, making a lot of mistakes here. So I would go finish, and I would wait for it to go to the return. And now if I take this value pattern right here and do pwn cyclic tech L, tells me my offset's at 18. Okay, so now I know my offset is at 18. I can just get rid of this here. I can try to figure out my plan of attack. So it's a statically linked binary. We know we're going to have to use some sort of rob chain. So the first thing I'm looking for is maybe this is a return to syscall challenge, which it is. So I want to look for a syscall gadget. And we see that there is a syscall gadget. However, when I was looking for string, there is no string, bin shell string in the binary, so that sucks. So we have to figure out how we can get the bin shell into the binary somehow. So if I just run this real quick and run a bunch of C's here, if we look at the registers, RSI right here is holding all of our user input, all the C's here, which means if we can put a slash bin shell into our user input, it'll go to RSI. So let me try this again. This might not work because I'm sending it that way. Okay, kind of did. So you can see it's in here. So I was looking for a gadget to move RSI to RDI so I can create my rob chain. And when I ran rob gadget, binary static, let's grep for move RDI, RSI. The only good ones I found were these move RDI, RSI, and then it jumps into some memory address here. So what I did was I had to find a return command so I could jump back to continue my rob chain. So then we had to go look for a ret gadget. And there was no decent one either. I found this one right here, not that one. Oh, here it is. So it calls xlatb, xlatb, and then return. I don't know what it does, but I just ignore it. It seemed, after some Googling, that it was safe to ignore. It doesn't really do much, affect our code. So I use this for return. And if we go back to our code now, yep, we have a pop RX gadget. We have a pop RSI gadget. And then we don't have a pop RDX gadget straight. I was using a pop RDX then return F, which ended up messing up my code. And I decided to just find another one, this pop RDX, pop RBX return gadget here. So to set up our rob chain, first I send in slash bin shell. Slash bin shell is 8 bytes. So we need 18 bytes to overload the return address. So we pad the rest with NOP instructions. So times 10, so that's 18. Then we have this gadget right here to move RSI to RDI. Then we send the return address, or the ret gadget, my bad. Then pop REX, then we put 59 in there because that's the syscall number for exec VE. Then we have to pop the RSI gadget, put 0 in there, pop RDX, RBX00, and then we call syscall, and then send the payload. And if we run this, we should get back a shell. There we go. And if we run this on the remote server, we should also, that was weird. Let's do this. Should also be getting a shell. And there we go. That's the flag. So yeah, that was 2 PWN write-ups that I have for this challenge, this video, whatever you want to call it. Still working on the CTF, so I'm gonna work on this one and this one. They actually just came out with this new challenge. I don't think a couple people solved it already. So yeah, see ya, losers.